I had I had just a random idea as I was browsing the OEIS, as one does. That's the what does that stand for? The something something of integer sequences, the Online Encyclopedia of Integer Sequences, I think. So they have, let me actually go find it. OEIS. Whoops. So you can look up integer sequences. They have kind of all different types of sequences. And one of the cool things you can do is you can listen to the sequences. So each number is mapped to a note in a Midi file. You download the Midi file, and then you can play that Midi file. So this is the, let me find a better one. Let's see. What's an interesting integer sequence? Uh, uh, Shoot, golden ratio digits. I want the sequence of digits in the golden ratio. Wait, what? Primes from merging of two successive digits. I don't know, this sounds like it might be interesting. Let's listen to this. This is just an example. So what you're hearing here, yeah, it's already on max. You're actually hearing, which one did I download? You're hearing these numbers mapped to MIDI notes. So 0 being the lowest note on the MIDI keyboard. I guess that would be a C0. And then the highest one being like a C8, maybe? I don't know. I think the MIDI range goes up to 128, but I'm not sure. But anyway, and then it just plays the note. So it's going to be high, 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 mid, low, 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 right? So if we go back to the start, it's a little fast, but anyway, that's what you're hearing. So I wanted to make something like this, and so that's what we're going to do. And I just looked up on Stack Overflow how to play MIDI in Java. So, I mean, I've done this before, but I don't know it by heart, so I looked it up. So we're going to create a new project, sequence to MIDI. Whoops. And we're just going to go, nope, source, new package, MIDI, sure, why not? Class, MIDI player. Oh, I forgot to open my chat. There we go. I doubt anybody's here yet because I didn't announce this. So anyway, what I want to do is I'm going to make just like the, I'm going to put the main method in here because this isn't going to be a very big project. I'll just run it from the main method. So I'm going to create a MIDI player. Goes new MIDI player. m.set function. I'm going to pass some kind of function in there. So this function will take an integer, or sorry, this function will take a sequence of integers, so 1, 2, 3, 4, 5, 6, 7, and it will pop out a different sequence of integers. So if I wanted to make the set of primes, if I wanted to get the sequence of primes, right, I would put in 1, and the function would pop out 2 if 1's not prime. And when I pump in 2, the sequence would pop out 3, then it would pop out 5, then 7, then 11, all the primes in order. But it would do it one at a time. So we're going to make a new class that's actually going to be an interface, because I would love to do function pointers in Java, but you can't. New interface. Function. And this is going to have one method, public, int. I actually should make this a class so it can store the previous value. Well, let's just see where we go. I could do it either way. So I'm going to set the function. So function f equals new function. Or you know what I could do? I can make the function just return true if it should return that integer. That's probably an easier thing to do. Boolean, what do I call it? Is in sequence. So basically what this function does, I mean, what the function class should do is I'm going to give it some code in one of the implementations, right? And then I'll just do an example. I'll do the prime one. That's a good example. So we're going to do prime function implements function. I'm going to get that. So the way to test whether something is prime is to test whether it's not prime, and if you fail, then it's prime, right? So I've written this before, but I'm just going to do it the lazy way. I could optimize this later if I want, but this is just an example. So int n is our input. So we're going to start at 1 in the main, in this class. Basically, I'm going to loop from 1 to 10,000 or whatever, some arbitrary large number. And I'm going to pass each integer into this, and if this function returns true, then it's part of our set, and that's how we're going to build the set. So for int, let me rename this input. So I equals 1, I less than or equal to, I times I less than or equal to input, I plus plus. If input mod I equals 0, return false. Right. So I'm going to write a quick unit test here. So for int I equals 0, I less than, let's just go to, now let's go to like 200. So this should print out all the primes between 1 and 200. If is in sequence I forgot to actually create the object I. Alright, so this should print out all the primes. I didn't really care what it's going to do for like 1. Let's see if it works. Errors exist? Not in this class. Okay, broke. What did I do wrong? So when my input is, let's say, 7, I could debug this actually. But let's just think about it, because I did something wrong. I should have printed way more than that. If input is 7, okay, I equals 1, I times I is less than 7, 1, or 7 mod 1 is 0. So it's going to return false. Huh. I did something wrong that's pretty obvious, but I'm not seeing it. Okay, 0 is prime, but nothing else is prime. What did I do wrong? Oh, I can't start at 1. Doi. I have to start at, I have to start at 2. Oh no, I have to start at 3, and then I'll just add a base case for 2. Input, whoops. Input mod 2 equals 0, return false. Because when I start at 1, everything's divisible by 1. Okay, so let's take these out. Alright. Yeah, that looks like all the primes. So that's an example of how the function works, right? You give it the code, and it will pop out true if the input belongs to that set of whatever numbers you want it to have. Okay, so that's what we're going to do. I can define the function inline here, so I will. I don't need to set function. Oh, the Midi player has to do it though. F. So public, let's make a constructor. I could make a constructor with the function as well. Private function. Just for completeness. Alright, and public void run. And this is where our main algorithm is going to go. But for now, I think our test is done. Oh, m.run. So if I run this, it should do nothing because we haven't put any code in there. Oh, also there's no main method because yep, it did nothing. Success. Alright, so here's how we do Midi. I'm just going to copy this pretty basic code. I'll just change what I want to change. Apparently we're going to need a try-catch. In good projects, I would never do this because this is really lazy. But this is just like a little test thing, so we're going to import this stuff. I'll just do it that way. Okay. Get channels, load instrument. There's a lot of white space in here. Alright, so this is how we turn notes on and off. So we're going to have some kind of loop around this code. And that's how, and every time we loop, we're going to advance the function by 1. Yep. So let's just test that this works. This should play one note. It should play whatever note 60 is. That's note 60. It sounds like a C4. Yep. So it's going to play them every 1 second. Let's speed that up a little bit. 4 per second. Alright. Alright, so 4 int I equals 0, I less than, let's say 1000, I plus plus. This is where we use our function. Int next note equals or actually, if function, oops, is in sequence I, then we do this. Otherwise, we don't do that. Yep. And so what I'm going to do is, oh, there is one thing I need to fix though. This is going to be I mod 120 max note in Midi. Highest note in Midi. It's 127. Alright, so I mod 127. Oh wait, the highest note is 127, so mod 128. So this sequence goes above 128. We can't play notes that high because it's impossible. So what we do is we just make it roll around to the bottom number again. So this should play every number from 1 to 1000. Let's speed it up actually. That's 20 per second, it's kind of a lot. Let's just do 10 per second just to test it. Uh-oh. Oh. So this should play every note in sequence. And it should do it like 9 times. I think it works. Okay. So now what if I only want to play... See, now I can do interesting things with it. Or what I can do here, just get rid of that for now. I can set new prime function, and now it should play all the primes, but I'm going to slow it down a little bit. So yep, it's playing all the primes. They are ascending as they should, but once it gets past 128, it starts again at the bottom. Velocity 100. What the hell is velocity? I thought that was the volume. Turn it down a bit. Oh. That's what was giving it that echo. Now it's only playing one at a time. Also, those low notes are kind of hard to distinguish, so I'm just going to fix this. We're going to start at... Let's start at note 20. Do I want to do that? That's slightly complicated. My brain's not really on right now. I'll do it this way. So if I mod it by 108, and then I add 20, I think that does it. Let me think about this in my head. So that will always be a number between 0 and 108. So this will always be a number between 20 and 128. And there should be no overlap. Is there? I don't think so. Let's just play every note and see what it sounds like. Let's go faster than that. 20 might be still too low. Yeah, that's still pretty low. I could do the same thing for the high notes. Oh, also, hold on, let me do it this way. Okay, that maybe is starting a little too high. Go down to 40. Oh, that's not going to work. I need to subtract a little more. 88. Yeah, those higher notes are kind of hard to hear. So we're going to cut off the top 18, I guess. And we can drop it a little bit. Just trying to get the range right. Yeah, that's fine. Okay. Do I still have... I don't need the other thing. Alright, so now I want to write an interesting sequence. So I'm going to create a new class. Uh, let's try twin prime gaps. Oh boy. Implements function. This is going to be like the hardest part of the whole thing, and I didn't even need to do this because I've already pretty much written the whole thing. All right. So, I'm going to get my prime function. This is basically an isPrime function, so I'm going to private boolean isPrime input, int input. All right, can I optimize this anymore? I don't really care about negative numbers, so this is already going to be pretty fast. Okay. So if n is prime and n minus 2 is prime, return true. Otherwise return false. Oh, since I don't support negative numbers, if n is less than 2, return false. This is just twin primes, though. This is not twin prime gaps. So this will return all of the numbers that are part of a twin prime pair, if I have done this correctly. I can get rid of this. New twin, yep. Let's see what this sounds like. See, it sounds kind of all over the place. Nothing really interesting there. But what I want is, so what I want to end up with is, so here are the primes, right? We're going to start with 3, 5, 7, 11, 13, 17, 19, 23, 27, 29, 31, not 27. 37, 41, 43, 47, 53. So these are the primes. The twin primes are, I want the gaps between twin primes. So I'm just going to put a 1 where there are twin primes. Right? So the twin prime gaps should be, well, we'll start here. It's going to be 0. The gap here is 1. The gap here is, well, some people define it as like how many whole numbers, so it's actually 4 between 7 and 11. And between here it's technically 2. I'm going to end up dividing all these by 2. 13 to 17 is 4. 19 to 23 is 4. This is 6. Oh, wait. We want twin prime gaps. So this is 19 to 29, 10. Wait, did I already mess up? Hold on, 13 to 17. Okay. Once these numbers start getting big, it gets a little confusing. 31 to 41 is another 10. And then let's get one more. So 57, 59 prime? Yeah, I think it is. So here's a twin prime here, and the difference between 43 and 57 is 14. Dividing all these by 2. So these are the twin prime gaps right here. 1, 2, 2, 5, 5, 7. What I want is the gaps between these. So it's going to be 1, 0, 3, 0, 2, etc. So I need a function that generates this, which is going to be pretty tough. So I have the function that generates these. That's this guy. So what I really want is another function. This is going to be pretty expensive when I actually run it. Is start of twin prime. And it's just going to be this code, but I'll change one thing, and it's going to be n plus 2. So if n and n plus 2 are both primes, return true. So I only care about the first in the pair. And I'll count the differences between the first in each pair, I guess. Okay. Let's do a unit test. Let's go to 500. Oh. So we're going to print I and the number after I. The prime after I, so is I plus 2. So this should print all the twin prime pairs up to 500. If I've done everything correctly. Uh-oh. Unsolved compilation. Oh. Yep, 3, 5, 5, 7, 11, 13. Alright, cool. So that works. They grow pretty fast, don't they? Alright, so now I have the first number of each twin prime. So each time that I go between one of these, I'm like differentiating it, right? Every time I go up a layer. Alright, so we're going to make a new function, private boolean, or how about public int get gap between last twin prime. So I'm going to document this a little bit. Given prime, given the first number of a twin prime pair, given the first number n of a twin prime pair, return the gap between n and the previous first prime of a twin prime pair. So what this is going to do is say for int I equals n minus 2, n greater than or equal to 3, n minus equal 2. So we're going to start at n minus 2 and just go to every odd number and say if is start of twin prime I return, this will always be an even number. I want it to be odd. So it's going to be return n minus I divided by 2. This should never error out unless n is very small, like if it's 1 or 2. Because if n is 3, let's just handle this now. If n is less than or equal to 3, return 1. We'll just ignore the first couple. And then this should always complete, because there's guaranteed to be a twin prime before any other twin prime down to 3. So this return should never happen. All right, and now, oh geez, get gap between last twin prime for n. So that's if n is a twin prime. So now we need a function to find the nth twin prime. Jesus. So if I wanted this to be performant, I would actually cache this in like a list. But we're just going to be expensive and brute force it instead. Okay. Okay, so that'll return something. So this function will return what will it return? Okay, we'll figure that out later. We want the get the nth twin prime. So for int count equals 0, for int I equal 3, I less than, oh boy. Oh, this is going to be a while. While I is less than 1,000,000. We're not going to go that high. If is start of twin prime. I wonder how long this is going to take to run. Maybe I should cache it now. I always say to people who learn to program, it's better to do things right the first time, and here I am not doing it right the first time, just because I want to kind of get this over with quickly. Sometimes that's how businesses do their thing. They say, hey, we just want this project, delivered in 2 weeks, regardless of how complete it is. And you're like, well, I wish I had another month, to make everything perfect, but, in the real world, that doesn't always happen. So if I is the start of a twin prime, you know what? I'm going to cache it. I'm going to do it right. Twin prime starts equal new array list. And this way, I don't need this at all. I just need an init method. This is my constructor. So I'm going to build this here. First I have to import it. Int I equal, we'll start with 3. I less than equal to 1,000,000, I plus equal to. If is start of twin prime, add it to our list. So the nth index of this list will be the nth beginning of a twin prime. And I could print it out. Let's do a smaller number. Let's go to 100. And then we'll return false, just so I can run it. And our unit test is going to say Unit test is going to say for int n in whatever this list is called, twin prime starts. So it should print the basically this left column here. So it should go 3, 5, 11, 17, etc. Yep. Okay, so that works. So we've built a list. I'm going to increase this to a bigger number. 100,000 should be good. Our Midi's not going to be that long. Okay. So now I probably don't even need half of these functions here. Here's my list of twin primes. So what I want is to, what am I doing? Get the gaps between these. All right, so if, all right, you know what? I'm just going to take a quick break because nature is calling. I'll be back in like 2-3 minutes. All right, we're back in business. Go back here. I'm just realizing maybe I should make this a little bigger because it's looking slightly small on the screen. Yeah, we'll make this a little bigger. Let's go to 18. And I'll just full screen this. Okay, should be a little easier to see now. Can I make this bigger? I think I can. Nope. In JMonkey I can, but not here. There we go. How do I change? I can't change the font size. That seems like an oversight. I should be able to do that. Java editor. Is it basic? This one? Aha! Okay. Alright, so what we're looking for is we're given an integer n. Oh, I made a mistake when I defined this. What I should be doing, because some sequences can have copies, like this one that we're about to write. So what I should do is get nth value. That's what it should do. And then I have to, oh boy. So my is prime. Oops, I didn't mean to do that. I should copy it, put it in my prime function, and then I less than, oh, I want the 0th element. I less than, so if I want to get the nth value, if I want to get the nth prime, I guess I just go forever. Put a really big number in there. Oops. I plus equal 2. Let's start at 3. Because we define 3 as our first prime. If is prime I, we do n minus minus, and then if n equals 0, return I. That should return the nth prime. Oh, this should be an int as well. Alright, what's wrong with my prime function? There's no default. Return. This should never happen, right? So when n is 1, this returns 3. When n is 2, this should return 5. When it's 3, it should return 7. When it's 4, it should return 11. What's up, Muck? I'm doing just a fun little short project of turning number sequences into Midi. I don't think this will ever work, or I don't think it'll ever get to this. Not for primes, unless n is bigger than that. And now I want to do this. Print out get nth value. We're going to start at 1 though. So this should print out all the primes up to whatever number. That's a big number. 3, 5, 7, 11, 13, 17, blah, blah, blah. Yep, those look like all the primes. So my prime function is done. Now I need to fix this one. So I have the start of each twin prime pair. And I need to find alright, so int first pair, our first base, equals twin prime starts get n. Oops, shit. Then we're going to do get n plus 1. And so we just return second base minus first base, I think. We have to handle errors if n is greater than, what did I go up to? 100,000. Okay, if n is greater than or equal to twin prime starts length size, return 0. Alright, so now I should have the list of gaps between twin primes. This is how I'm spending my Tuesday? I don't even know what fucking day it is. Okay, it's Tuesday. I took the day off because I woke up with kind of a headache, and I didn't really get any sleep last night, so I woke up at noon, took the day off. Okay. So I've already tested that that works, so I'm going to do that, and then I'm going to comment this back in. Oh, yeah, people say it's going to hurt for a while. My mom still remembers when she got her smallpox vaccine, and it was pretty much the same thing. Your arm feels like a motherfucker for a few days. I still haven't gotten mine. I'm either one of two things is going to happen. I'm still working from home. Our company has not forced us back into the office yet. So I haven't gotten the vaccine because I just never go out. I never interact with people. But one of two things is going to happen. Either they make us go back to work like at the end of the year where like I'm the only unvaccinated person so I won't need to get it, or they'll make us go back in like a month and I'll actually think about getting it. Anyway, so let's see. So I'm just testing that my function up here works. Okay. So we're going to loop from 1 to 500 if f dot get nth. Oh wait, we just want to print the nth value, right? Whoops. So wait, first, actually, I probably should have left that code here. Got a code with only your right hand like verdant. Ka-ching. Oops, for int I in twin primes. I just want to get this list in Notepad real quick. Let's comment this out. I'm going to bring up my Notepad++. These are all the twin prime beginning numbers, so the beginning of each pair. Yep, so 3 to 5, 5 to 7, 11 to 13, 17 to 19. So these are the first in each pair. Right, so I just want that in Notepad, so when I run this, whoops, when I run this other code, this should print out, wait, what? Oh, that was old. I want to print out f.get nth value. So this should print out the gaps between twin primes. That's interesting. Oh, they're always going to be even, of course. Is that right? Between 5 and 11 is 6. Wait, what? I'm missing the small numbers, so this should be a 2. So, yeah. Oh, because it started at 3. That's probably why. So it's 6, 6, what's that? 8? No, 12. 17 to 29 is 12. That should be 12. 4159 is 18. Okay. So I've got all the gaps between twin primes. The only thing is I'm going to divide this by 2. This is what I really want. Like how many primes are in between? Yeah. 3, 3, 6, 6, 9, 6, 15, 3. These are all divisible by 3. Why are they all divisible by 3? That doesn't seem right. Yeah, they're all divisible by 3. really? So we get rid of 3. All right, 5 to 11. So there's 7, 9, 11. Okay. From 11 to 17, 13, 15, 17. All right, let's divide by 6. All right, this will fit within the Midi spectrum. All right, so this works. Now let's see what it sounds like. So I'm going to play the Midi, if you weren't here earlier, Muck. I'm assigning each of these numbers to a note in ascending order. So this is note, I made the lowest note 30, because the notes lower than that, you can't really hear them. So this is going to be like a C3 or something like that. And this will be the C sharp, and this will be D, and that'll be D, F. Right, so that's the idea. So the higher the number, the higher the pitch. Let's see what it sounds like. So there's like a little bit of structure, but not much. So anyway, that's what the twin prime gap sounds like when it's yeah, the random high notes. Then I can create another function that's like, show me the digits of pi or something like that. Now, I could write the algorithm to figure out all the digits of pi. There's something called the Spigot algorithm that lets you do this. I'm not going to do that. I'm just going to paste pi as a string and then just read each number. Pi. No, I want the fucking 1 million digits of pi in one page. Here we go. Yeah, we'll copy the 3 as well. I'm just going to take like a lot of these. Actually, yeah. Okay, so we've got a really long string. But we're going to get rid of this decimal point. And then we're going to do, implements function. We're going to get the nth value, return integer, parse int. Digits of pi caret n. Parse char. Okay, there's an easier way to do this. I'll do digits of pi caret n. And I happen to know that 0 is character 40. Let me get my ASCII chart. I think it's 40 or 48. Oh, Jesus Christ, Google. Just give me the fucking... Okay. Where is ASCII? 0 is 48 in decimal. Okay, so we're just going to add 48. Yeah, but math.pi is stored as a float or maybe a double, so you get limited precision. Crap. Oh, it says it right here. So this only contains like, 15 digits or whatever. So that's why it's not good. That wouldn't be a very interesting song, a 15-note song. So we're just going to do it this way. So now we're going to plug that in instead. New digits of pi. Well, this is what the digits of pi sound like. what might be fun to do is find the gaps between these, like how far away from each other they are. So int a equals this, int b equals n plus 1, and return a minus b. So this will find the difference between one digit and the next. So this will be 2, then it'll be 3, then 3, then 4, then 4, then 7. You get the idea. It sounds just as random as the digits themselves, because they pretty much are random digits. Now, something that I could do, if I didn't want to do something else instead with my time, is I could turn this into a bunch of binary digits and convert it to like base 64, because that would sound better in Midi. I'm thinking about it. Memory addresses. What about memory addresses? Memory addresses of what? Alright, well I kind of already have that, right? Because I can get the memory address of these integers. Just get random memory addresses. It's just going to sound like noise, though. I can do this inline. Function f equal new function. I'll just define it inline right here. Alright, so object O equals new object. Unsafe equals new unsafe. Will it let me import unsafe, or do I have to explicitly... Oh, shit. Sun, misc, unsafe. What? Access restrictions, not API. I don't care. Oh, it's not part of JRE 1.8 anymore. Shit. What replaced Java unsafe? It's still there. Is this just a warning? Or will it actually compile? It's a warning. Okay, I don't care about that. I used to get address. I don't want that. Get object. How do I get the memory address of an object? Oh, I think I have to allocate it myself, don't I? What does this return? Oh, jeez. Oh my god. Why is Eclipse so bad sometimes? Ugh. This returns an object. Okay. Is that what I want? What else can I do in here? Allocate memory, returns a long. Give me 100 bytes. Alright. I'll just play the first 100. I mean, it's going to be random, right? Return. Oh, I just want a random. Yeah. Return address. It's just going to sound like noise. See, it's just noise. Oh, wait. No, I did the digits of pi. Hold on. Put that in there. I was like, why are all the notes so low? It should be more of a spread. Ah, crap. Uh-oh. Am I not able to get in here? Uh-oh. Okay. How do I make I know how to make like fields and stuff public. How can I make a class public? Oh, I have compilation problems. That is a compilation problem. Really? Oh, one thing is I need to do that. Huh. Anyway, I'm not going to do that because it's just going to be random noise anyway. Because Java's just going to allocate whatever random memory address it finds on the heap, right? So I already know what it's going to sound like. That's not going to be interesting. So Verdant, if you weren't here, I did twin prime gaps. So this is what the gaps between twin primes sounds like when they're turned into notes. Isn't math beautiful? Alright, so where is, let's see, OEIS. Isn't there like a home page where there's like really cool... Somebody did Pascal's triangle. They say this one sounds okay. Let's see what this one sounds like. Yeah, it's just going to be a bunch of pyramid sounds. That's not very interesting. There's a fractal there, divisors of n. Prime gaps. I already did that one. Boss music. Oh, yeah, I could do probably golden ratio digits. Oh, actually, you know what might be interesting? So there's an infinite expansion of how to get to some of these transcendental numbers, right? You can write them all as they equal x plus 1 over something plus, or 1 over x plus 1 over x plus blah blah blah. But the 1 over can be something else. I forget what those are called. Let's see. Calculating pi. 5 ways to calculate pi. Let's see if somebody... That's an infinite series. I want the... No. Surely somebody's got to have this online. I forget what it's called, but basically it's like a it's like an infinite division expansion where each term that you add, this one, continued fractions. So I could plot these numbers 3, 7, 15, 1, 292, 1, 1, 1, or whatever. What's it actually called? It's just a continued fraction. All right. So the interesting thing about the golden ratio is the continued fraction sequence is 1, 1, 1, 1, 1, 1, 1, 1 all the way down. So it's 1 plus 1 over 1 plus 1 over 1 plus 1 over 1 plus forever. But E is not like that. How about continued fraction E? Jesus Christ. What is this crap up here? That's just an image. Do they have the actual... Is that it? Play Graham's number. We'd be sitting here until the end of the multiverse. That's the positive integers. I don't care about that. Wait. See, this is 2, 1, 2, 3. Huh. Oh, here it is. It's this sequence. So these are the continued fraction bases of E. We could plot this in. I'm just going to steal this. Yep. Return values n. So we can see what this sounds like. It'll throw an exception at some point, but that's fine. So these are the continued fraction bases of E. That is exceedingly regular. I picked E because it's more interesting than pi. What's the expansion for pi? There's like a 200 in there, right? Continued fraction for pi. Yeah, see, these get really big. But we'll try this one too. Jesus. Yeah, then we ran out of our array. That sounds like something Elton John would play. Yeah, Breath of the Wild. What other interesting numbers or fractions could we do? Breath of the Wild boss. I've heard some of the Breath of the Wild soundtrack. I don't understand why people say final boss, Molduga battle. I don't know why some people say that Breath of the Wild has a good soundtrack. I thought it was shit. Yeah, that's pretty bad. Anyways, so I know that they're called continued fractions now. What are some other interesting sequences that we could come up with? Yeah, I mean, like when you find an item, that sounds okay. Think of what other cool sequences could we do? I'm going to delete that one. Or I'll just rename it to sandbox. All right, I'm taking suggestions now. What's a sequence we could build or look up? Oh, geez. Yeah, this part sounds like what I just played. Okay, negative numbers, no good. What is that? What sequence is this? Is this like an actual song? What sequence is this, Muck? Oh, it's an actual song. You just want me to play it. I don't recognize it looking at the numbers, but we'll give it a go. Yeah, it's for release. So I've shifted it because the low notes are too low and the high notes are too high, so I've like compressed the range, so that's why it's off key. If I just did this, then it would actually sound like what it's supposed to. Actually, it sounds an octave too low. I'm not here to play music, I'm here to play mathematics. I'm trying to think of some interesting numbers or functions that I know, but it's been so long since I've taken calculus that I forgot all of them. Yeah, but there's no function to define a song, unless you make it arbitrarily complicated. Isn't that the Fibonacci sequence? Wait, what? Hold on. A of 2n equals n. A of 2n plus 1 equals a of n. Oh, that's the one that goes back and forth and always resolves down to 2. I forget what it's called. That's not a sequence though, right? That's just a rule. I guess you could plug in n and get the sequence. Yeah, I'm not using complex space here. So most fractals are not going to be possible. God, what else could I do? How about if I convert... I want to do something with the bits of a number. So like take the bits of n as a float or something like that. Will Java even let me do that? I can get the value as a byte. I don't want to do that. I want to get... That does rounding. I want to get just the bits. Float to int bits. Was this return? Damn it. What does it return? Come on, Eclipse. Jesus Christ. I want the... It returns an int? Oh, I guess it returns... Okay, I see. I can just do that. So this will return the int representation of the float representation of the int. Wait, what? There we go. Understand? I don't know. I have less code than your table editor right now. So this, what it's going to do is it's going to take an integer. It's going to convert it to a float, which is going to have some arbitrary bits, I think, maybe. And then it's going to just return the integer equivalent of those bits. And after the modulus, maybe we'll see some patterns. Let's find out. That actually doesn't sound too bad. This is really interesting, actually. I like this. Okay, I think I'm probably going to end the stream there because, like, I did everything I want. Throw it on YouTube and people can play around. I'll also probably throw the source code up on Git and make it public, and I'll link to it in the YouTube video, but not Twitch because Twitch sucks. I took the day off because I had a headache all day, or all night last night, and I didn't get any sleep. So I woke up at like 11:30 or something. Just decided, meh, fuck it. I told my boss at like 8 a.m. because I was still awake, and I'm like, nah, I'm not going to work today. He was like, okay. This is like the most melodic sequence that I've run into in writing this thing. This is the int representation of the float conversion of the given int. There's actually a good amount of structure in there. Anyways, yeah, I'll cut the stream and then work on some other stuff. Oh, let's see. Is there stuff in my Discord client I don't want to show on stream? Probably. Let me go to a different screen real quick. Yeah, okay. Okay, so as long as I don't show this stuff at the top. Those are public. Okay, they should probably be private, but that's alright. I was going to show Verdant how I... Okay, let me go back in here now. I was going to show Verdant how I don't want to do move skills. I want to do... Where's the start tournament thing? Here we go. So the way that I do the Discord thing... So for Muck and Vetch, who don't know about this project, I have a... Actually, I'll just run it. So I've made a Guild Wars sealed deck generator. Oops. So it'll list some tournaments and shit. And then if you're in a tournament, which I am because I've debugged it, in a few seconds it should pop up for me. Is Discord muted? Oh, it is. Okay. But anyway, when the tournament starts, it will it'll create which group am I in? I don't actually know which team I'm on. I'm an admin, so I can see every group, but like I would be on one of these teams, right? I wouldn't see both of these. So it would be like, hey, you're on this team, and then all your other teammates would be here. And when you go to the site, you can like make your build, right? And it gives you the template codes and all. So I was going to show Verdant how easy it is to do that. So if you use my Discord client, which is way better than everybody else's for some reason, I'm create a category, privatize the category so nobody can get into it, create a text channel, create a voice channel, and then for each person in there, you can give them permission to see it. Easy peasy. Oh, you're going to use these. Oh, wrong page. You're going to use template codes for DBO. Oh, really? I know that you showed me on the website. Yeah. Really? So the website supports them, but the game doesn't. That's fucking stupid. You can swap skills in and out freely, though, in the game, right? Do you know how they're decoded? Like, do you know how to generate those codes? Oops. Because let's see if I can source main resources JS lib. So here's how Guild Wars does it. So here's the, yeah, here it is. Here's the code to make a template code. It's a little complicated. His trees and skill reset items. Ugh. But yeah, the Guild Wars one is pretty interesting. Basically, each profession is represented by a certain number. You just add the professions first. Then you have all the attributes. Whoops. I don't work with attributes. People can choose their attributes in game, so I don't really support that. I just set it to you don't have any. And then for each skill has a unique number, and you just do that. So what's interesting is ArenaNet. Where did I put it? ArenaNet assumed that they would need 5 bits for each attribute. So that's a max of wait, hold on. That's the max bit length that we need. But what is it in? Hold on. ArenaNet assumed. What did they assume? I think they assumed that they would have like up to 128 attributes or something like that. Like they would add how many? Each profession has like 5, right? 4 or 5. So they assumed that they would have like 20 professions in the game at some point when they introduced. I guess this was Nightfall when they debuted this. So that was kind of cute. Anyway, I have nothing else to talk about. I've done my MIDI player. I'm gonna cut the stream and do something else that's not Baba Is You because I don't feel like Baba Is You today. All right, bye guys.